Hey guys, let's do some physics. First problem, look at that circuit there. It says the charge passing through time. I know charge over time is called current. It's coulombs per second. So in other words, I want to figure out which one of these has the most flow through it. Well, all of it flows through that first one, and then it splits up. Some through the first path, some through the second path, some through the third path, depending on their resistances. But it's all going to come back together at point A to complete it. So point A has got to have the most. Now looking at question number 2, that's a combination circuit, so I'm going to redraw this like I taught you. 9 volts, and then it goes through 100, then it goes to either 120 or through 150. And then it comes back to for 0 volts. That's the current path. Now the 120 and 150 are in parallel. So now I'm going to find the total resistance of those two using that equation. And I find the resistance to be, I think, 66.6. Yeah, I'm on it. So now I'm going to redraw the picture and say that the 120 and 150 are equal to a single one of 66.6. My cat agrees. And since those two are in series, it's equivalent to a single resistor of 166. So now it says rank the resistors by the voltage across each. Okay, looking at our original picture, I know that some of the voltage is used by the 100, called V1, and then the rest is used by 120 and 150. They're both the same. But look at the second picture I just drew. It's a lot easier. In series, more resistance is more voltage. So the 100's got more than the 66. And the 66 is really those two in parallel, so those two are going to be the same. And that's how I got that right there. Now for the next one, the current through each. I'm drawing it. All the current goes to the 100, and then it splits up. So the 100's the most, and then more is going to go through the less resistance one. And that's how I got that. Now, I'm going to replace the 120, so I'm going to circle it so I know what I'm talking about. If I change it, would it change the voltage ranking? And the answer is going to be yeah. And here's how I knew. If that 66.6 becomes more than 100, then the two in parallel will have more voltage than the 100 one. How do I get it to be more than 100? I have to change the 120 to a really big number. So when I do the math, it ends up with a total of more than 100. So you can see right here, I'm saying if the 120 gets replaced with something really big, so that when you combine it with the 150, you end up with more than 100, then you're going to have a different ranking. It'll go, those two are more than the 100. And finally, is it possible to replace the 120 so it's a different ranking for current? Yeah. All I got to do is just make more current go through the 150, which means that the other resistance to 120 has got to be now more than 150. If the 120 gets replaced with more than 150, it'll have the least amount of flow. Let's flip over to the back. Ooh, this looks pretty ugly. Once again, I'm going to redraw my picture. The 200 and 300 are in parallel, but then it comes back together and then splits off again into the 400 and 500. So I'm going to remind myself that those two sets are parallel, but those two parallel sets are series to each other. So what I did is I found the resistance using my equation to be those values for each. As I showed a little example here of me doing it. So my new picture starts off with 9 volts, goes to 120, goes to 222, and ends at 0. And again, those are in series now. So it's kind of like I could say those two get replaced by a single one of 120. Same with the bottom one. So if I add those two up, I get a total resistance of 342.2, and that's what we call the equivalent resistance. Now to calculate the voltage on each, it's kind of tough. What I'm going to do is I'm going to quickly make a little VIR diagram here using the two combinations. I solve for the total current using V equals IR to be 0.026 whatever. And now I know that that's going to be the same for both of those combinations. Doing V equals IR, I find the voltage to be the numbers you're about to see. 3.15 and like 5.84. And since they're parallel, those two share the same voltage. So the 200, 300 have the voltage of 3.15. And other ones are going to have the 4 point something. But now I've got to find the current through each. Is the current through each one going to be 0.0263? No, that's the combination of them. So I'm going to make a new table here just to kind of expand outwards. And I'm going to draw on the different resistances, 200, 300, 400, 500. Now the 200, 300 share the same voltage. the 400 and 500 share the same voltage as well because they're in parallel. So I'm going to do V equals IR. I'm going to solve the current for each. Even Victoria agrees. Now, if you add those two up, you should get 0.0263, which is what you do. So those are the currents for each one. We just found the current through each resistor. Finally, the 500 ohm resistor is now removed. What's going to happen? Well, let's draw a picture of it. Looks a lot simpler. The beginning pair hasn't changed in terms of resistance, so it's still 120. So now I get 520 ohms as my total resistance, whereas before it was 342. So the overall resistance really went up. So what does that mean? Well, at the same push, you're going to have less flow, so the overall current goes down. Now, what I'm going to say here is that because it now has more voltage than the other part, it's going to have more of its share of voltage. Once again, what it's saying is that since it's way larger than 120, it's going to have way more voltage than the 120. So the 120 loses its share of push, the 400 gains a share, so it has more voltage because it went from the lower